Hello everyone, welcome in our next video lecture. Myself Daljit Kaur, I am welcoming you on behalf of Physics Mate Easy Kota. In this lecture, we are going to study about the topic electronic devices. So, in this lecture, we are going to learn about the different types of the extrinsic semiconductor. The first one is the N-type semiconductor, which means that doping the tetravalent semiconductor with pentavalent impurity. We can take the pentavalent impurity, for example, arsenic, which has 5 valence electrons in its outer shell. When arsenic atom is added into the semiconductor crystal, it replaces silicon atom and settles in the lattice site of replaced silicon atom, and this arsenic atom form 4 covalent bond by sharing its 4 electrons with neighboring 4 semiconductor atoms. But what about the fifth one? The fifth valence electron of arsenic remains unaccommodated, so this electron loosely bound to its parent's nucleus and is detached easily even at a room temperature. So now the electron become free and it move randomly through the crystal. In this way, we add a large number of the free electrons, and the large number of the free electrons are available in the crystal when we add a small amount of the arsenic to the crystal structure. So in this type of the semiconductor, there is a large number of the free electrons. Majority charge carriers in this type of semiconductor are electrons, and the minority charge carriers are holes, which are thermally generated. Thus, this type of semiconductor is called as the N-type semiconductor, and this is the one type of the extrinsic semiconductors. Since each pentavalent impurity atom donates one extra electron to the crystal, so it is known as donor impurity. Next semiconductor is a p-type semiconductor. When suitable trivalent impurity is added to the pure crystal, for example in germanium crystal or a silicon pure crystal, we get extrinsic semiconductor, and that extrinsic semiconductor is known as p-type semiconductor. So in this case, the trivalent impurity atom, which has the 3 valence electrons, are added, and the trivalent impurity atom is also known as the acceptor atom because it creates a hole which can accept an electron from the neighboring bond. So, a trivalent impurity atom, say indium atom, which has the 3 valence electrons, when such atom is added into the silicon crystal, this atom replaces one of the silicon atom and settle in the lattice site of replaced semiconductor atom. So, this indium atom form 3 covalent bond with the neighboring 3 silicon atoms, and the fourth bond remain incomplete, which has a deficiency of one electron. So this deficiency of electron is called hole. So we can say in the figure also there is a creation of the hole, and this hole always behave like a positively charged particle. Then this hole start attracting the electrons from the neighboring covalent bond to fill itself. Now a new hole is created at a side from which the electron has been attracted to fill this hole. In this way, a number of holes are formed by adding more and more trivalent atom in the semiconductor crystal. So here are holes created by the acceptor atom. Hence, holes are the majority charge carriers and electrons are the minority charge carrier. The semiconductors doped with acceptor type impurity are called p-type semiconductor. And why this is called as the acceptor type impurity? Because each trivalent impurity atom accepts one electron from the valence band of the silicon. So it is known as acceptor impurity. And this semiconductor is known as a p-type semiconductor. So now the question comes in our mind, what is actual definition of the hole? Hole in actual it is vacancy, or it is called as the absence of the electrons in the bond of the covalently bonded crystal. It has the same mass as the removed electron. It is associated with a positive charge of magnitude small e. It means that it shows the nature opposite to that of the electrons. So now here is a comparison between the p-type and the n-type semiconductor. We can clearly observe that in the p-type semiconductor there is a large number of the hole formation. So the holes are the majority charge carriers, and for the n-type semiconductor there are the large number of the free electrons which behave as a majority charge carrier. Now to recall the concept, here are few questions as assignment. Number 1, what is hole? Number 2, name a charge carrier in n-type semiconductor. Number 3, what type of impurity is added to obtain p-type semiconductor? Number 4, what type of charge carriers are there in a n-type semiconductor? So thank you for watching. Take care. So in the next part we will discuss about the PN junction. Take care. Have a nice day.